So welcome back to the class second lecture of binomial distribution. So in the first lecture, we did some we introduced the binomial distribution, right? And if you remember that how many properties were there in binomial distribution? How many? 4. Number 1 was the trials were fixed. The trials were fixed. The trials are fixed. And second, there will be 2 outcomes: success or failure. Third, the trials are independent, and the fourth one is the probability of success should be constant in throughout the experiment or throughout the trial. Okay, so next question number 9. So when people visit a certain large shop, on average 34% of them do not buy anything. So probability of do not buy anything is 34%. So the probability of not buying anything is 34%. 53% spent less than $50. So 53%, some of them spent less than $50. Less than $50 is 53%, that is 0.53. Next, and 13% spent at least $50. So probability of some of them spent at least $50 is how many percent? 13%. That means 0.13. Okay, number 1. 15 people visiting the shop are chosen at random. So 15 people visiting the shop are chosen at random. So n equal to 15. Calculate the probability at least 14 of them buy something. So they are asking me to find the probability out of 15, there will be at least 14 that buy something. That means what is the probability of success here? Buying something is the probability of success. Buying something is the probability of success, isn't it? Clear? So now you need to care about to find the probability of buying something, and that is our probability of success. So probability of success is what? Buying something. Buying nothing is 34%. So buying something will be 1 minus 0.34, and that is 0.66. Clear? So the probability of failure will be 34%, isn't it? 0.34. Clear, Baba? Next. So the question says, out of 15, at least 14 of them will buy something. So that means probability of X should be more than equal to 14. Tana? Probability of X is more than equal to 14. That means either the X will be 14 or the X will be 15. Is it okay, Baba? Clear? Either it will be, come here. Either it will be 14 or it will be 15. So that means out of 15, I have to choose 14. Clear? Out of 15, I have to choose 14. And 14 of them will buy something, and one of them will not buy anything. So that's the rule of the binomial distribution, isn't it? So what's the probability of success here? 0.66. What's the probability of failure? 0.34 plus. So out of 15, I have to choose how many of them? 15 of them. Then, out of 15, I have to choose 15. So 15, C15. So 15 of them will buy something, and none of them will buy anything. Clear? So that is like 0.66 to the power 15 times 0.34 to the power 0. So let's find the probability. So what's your answer? Okay, Baba? Okay, so what's your answer? 0.0171. Done. Next. N people visiting the shop are chosen at random. So now I don't know how many people were there at the shop. The probability that none of them spend at least $50 is less than 0.04. None of them spend at least $50. So first of all, reading this line, like if I ask you, what is the probability of success here? None. What is the probability of success here? Yeah, 0.53. Yeah. That means probability of success is what? Spends at least $50. That's the probability of success. Spending at least $50. That's the probability of success. Spending at least $50. That is our probability of success. Clear? Spending at least $50. That is our probability of success. Clear? Spending at least $50 is our probability of success. None of them. None means what? What will be the value of X? None of them means what? X is 0. So now if I ask you, what is the probability of success if X is 0? And that is less than 0.04. Isn't it? Suppose if I rephrase it again, N people visiting the shop are chosen at random. The probability of 0 of them spending at least $50 is less than 0.04. So what is the probability of success here? Spending at least $50. Clear? So now in number 2, so probability of success is spending at least $50. Yes, Baba.
Probability of success which is spending at least.
Because the question says none of them, none means just take out of this line. Like suppose in the first question, it says 14 of them buy something. So buying something is a probability of success. Clear? Next, none of them. So just erase this line. Spends at least $50. That means spending at least $50 is the probability of success. Clear? So spending at least $50 is the probability of success. And what is the probability of spending at least $50? Spending at least $50 is 0.13. At least $50 is 0.13. That is our probability of success. Spending at least $50. That is our probability of success. Clear? So this is 0.13. So what about the Q then? 1 minus 0.13. That is 0.87. Is it okay, Baba? Somehow.
So what about the 0.04?
Read the question again. Read the question again. Okay, suppose if I ask you, in this line, which one, in the English language, which one is the subject here? In the English grammar, which one is the subject here? Labid.
None of them spends.
I said, which one is the subject here? And which one is the object here? Eliza, which one is the subject in this line? In this, I marked this line. Which one is in English language? Which one is the subject here in English grammar? Huh? Huh? The probability is the subject. The probability is the subject. And which one is the object or the predicate? No. Okay, it's okay. The probability is the subject and is less than 0.04 is the object. That means what? The probability is less than 0.04. That is our 0.04. Do you understand? The probability is less than 0.04. You didn't understand? Of what? Of what? It will be different case. But the thing is like the probability is less than 0.04. Do you understand? You are asking me about the 0.01. What is 0.04? Tana, you got confused with this thing. Like, sir, if it is 0.87, if it is 0.13, what is 0.04? Isn't it the case? So the probability is less than 0.04. Clear? Okay, of what? Now I'm trying to make you understand of what. So probability is less than 0.04. Okay, now, okay, shh. It says that none of them, or it means what? 0 of them spend at least $50. So, what is the probability of success here? 0.13. Right? So, X is what here? X equal to what? 0. So, probability of X equal to 0 is less than 0.04. None of them means what? 0 of them. So, X is what? 0. Clear? Do you get that? So, probability of X equals to 0 is less than 0.04. Do you understand? Sure. Clear? So first of all, we understood the subject and predicate. The probability is less than 0.04. Done. And which probability? For X equal to 0. Because the probability of success is spending at least. Clear? This is the success. So for the success, X will be 0. Clear? Okay, now. So now if we apply the formula. So X equal to 0 means what? Out of N, so there is the question says there is N customers. So out of N, there will be 0 customers. 0. Clear? Who will spend? So this is the probability of success, and not success will be what? N minus 0, isn't it? Clear? And that is less than 0.04. So success is 0.13 and not success, that means failure is 0.87. Clear? Mahira? কোনটা বুঝে নেব? X is what? None of them is spending at least, spend at least $50 is X. Number of people who are spending at least $50. So it's like basically number of people. X is what? Number of people spending at least $50. Spending at least $50. Clear? So now the question says X is 0. None of them is what? X is 0. So probability of X equal to 0 is less than 0.04. Clear? So now just apply the formula. So NC0 is 1 times anything to the power 0 is 1, and that is 0.87 to the power n. That is 0.04. Now just do the trial error method. Clear? We don't need to use log. You can use log, but it's not necessary. Just use the trial and error method. Like you were going to do some trials. Clear? So if I write, obviously use the calculator. You can log. Yes, you can use log. There's no mark here because no. So that means you can use log. Yes. You can solve the equation, but the problem is it is, so maybe you will understand which will be greater than or equal to, greater than or less than. You will be understanding, but many of them will not understand this. So let's say, so I'm writing 0.87 to the power X. So make a formula in your calculator. So 0.87 to the power X. 0.87 to the power X. I think every one of you can use the calculator with the X button now. Then press calc and put some values of X. So let's say I'm taking 10. So this value has to be less than 0.04. Clear? 0.04 means what? Less than 0.04 means it will be 0.39, 0.38 or something. Clear? Do you understand? 0.39, 0.039 or 0.038. Clear? So suppose if I take X is 10, so what's the value? 0.24. Is it less than 0.04? No. So let's increase the values of X. So let's take X is 15. 0.12. Is it less than 0.04? Clear? No. Then let's increase the, is it further? 20. 0.06. Is it less than 0.04? No. So if I take 23, okay, I got 0.041. Is it less than 0.04? No. So what will be the next value? It will be 24. Let's see. See, 0.035, which is less than 0.04. Clear? So the n will be 0.04. Do you understand? So after trial and error method, I am choosing n is 24. That means if I take n as 24, it will be less than 0.04. Is it okay, Baba? Clear? Yes, Baba. Bolo. Acha, log the last thing. N is number of trials. It can't be a fraction. It has to be an integer. Clear? Done? Okay. Next. So now there are some topical questions from some question papers, and these maths are very easy. So do you remember what's the expected mean formula for binomial distribution? Ex equal to what? NP. And if I ask Huzaifa, what's the variance formula of binomial distribution? Oh, he doesn't know what he's saying. ক্লাসে ছিল না ওইটাই তো আচ্ছা Umair, if I ask you, suppose what's the formula for variance in binomial distribution? Umair.
Sorry, I forgot.
Aisha, see, same, na? Acha, so what's the formula for variance in binomial distribution? NPQ, isn't it? NPQ. Okay, now, the first question of topical question paper. Topical questions. The mean number of defective batteries, the mean number of defective batteries in the packs of 20 is 1.6. So the mean is 1.6. Clear? The mean is 1.6. That means what is given? EX is 1.6. In the packs of 20. So that means 20 things are given. So what is 20 here? N is 20. Mashallah, N is 20. Use binomial distribution to calculate the probability that a randomly chosen pack of 20 will have more than 2 defective batteries. So what they're asking me to do? Probability of X is more than 2. Probability of X is more than 2. So probability of X, so they're asking me to find the probability of X is more than 2. Clear? Probability of X is more than 2. That means what? It will be 3, 4, 5, 6, 7, 8. So probability of X is more than 2 means what? 3, X will be 3. Yeah, 4, 5, 6, ... up to 20. Then, so which one is missing? So we have to find this probability. So what are the numbers missing? 0, 1, 2. So what we can do, if we take the total probability 1 and subtract this 3, we'll get this answer. Isn't it? Clear? So what you can write, 1 minus probability of X equal to 0 plus probability of X equal to 1 plus probability of X equal to 2. Isn't it? That's the case. So now, do we know the value of the probability of success? No, we don't know the value of probability of success. So Mahira, what to do? How to find the probability of success? Yes, Babu? How are you going to find the probability of success?
So এখানে like success কোনটা হবে?
Defective batteries. Yes, Babu?
Expected mean.
Formula there. So you can use the formula for expected mean. So what's the expected mean formula? That is NP. And that's equal to what? 1.6. So N is what? 20 times P equal to 1.6. So we can use P here. So what was the value of P? 1.6 divided by 20. That is 0.08. So P is 0.08. So what will be the value of Q? 1 minus 0 P. That is 0.92. Is it okay, Baba? Clear? So let's use the formula 1 minus. Out of 20, 0 will have defective batteries. So just apply the formula 20C0. 0 will have defective batteries and not defective will be 20, isn't it? Clear? So what's the probability of having defective battery? 0.08 and not defective battery is 0.92. Plus. Next is out of 20, 1 will have defective batteries and 19 will not have any defective. Clear? So that is mainly 0.08 times 0.92. Is it okay, Baba? And the final one. Out of 20, 2 will have the defective batteries and 18 will not have any defection. So that is 0.08 times 0.92. So what is our final answer? 0.212? Is it 0.212? Okay, so I'm not doing that thing on the calculator. I'm just trusting you. So 0.212. Done.
So to show like our calculation.
Because S1 is not like, they don't care about how you're doing the calculation inside a calculator. This is for P1. They're showing everything is on P1 in pure maths. Clear? The next one. Okay, a biased die was thrown 20 times. Okay, the number of fives was noted. Number of fives was noted. That means X is what? Number of fives. X is number of fives. How many fives you are getting in 20 throws? That is X. Clear? Number of fives. Acha. What is the probability of success here? 1/6. That means getting a 5 is the probability of success. Clear? Getting a 5 is probability of success. Clear? So probability of success is getting a 5. That is 1/6. So what will be the probability of failure? That is 5/6, isn't it? Mahira? Atik? Clear? Next. Oh, yeah. That's the bias die. So we don't know. Yeah, very good. So probability of getting a 5 is the probability of success. Clear? It's a bias die. Sorry, I forgot the word. Okay, so the experiment was repeated many times. And the average number of fives was found to be 4.8. So that means EX is 4.8. So EX is 4.8. And how many times it was thrown? 20 times. That means N is 20. And what's the formula for EX in binomial distribution? N into P. So NP equal to 4.8. So N is what? 20. P is, we don't know. That is 4.8. So P equal to 4.8 divided by 20, 0.24. So getting a 5 is the probability of success. So that is 0.24. And it will be not getting a 5. That will be 1 minus 0.24. That is 0.76. Now the question says, find the probability in the next 20 throws. The number of fives, that means X, will be less than 3. Isn't it? Number of fives means what? X. X will be less than 3. Elijah, is it clear? Fahad? Sahil? Fatima, do you have any question? So the number of fives will be less than 3. That means X is less than 3. That means what? Doing the same calculation, either X will be 0, or X will be 1, or X will be 3. Or X will be 2, sorry. X will be 2. Clear? These are the case. And now I think this is the same calculation as we have done before. Same calculation, same type of calculation, just changing the values. So Nusra, what's the value? What's the answer? Hofyong, can you tell me the answer? Hofyong?
Sorry, I didn't finish solving.
Okay. Where are you? So have you got 1.109? So let's say I'm writing 0.10. Clear? Is it okay, Baba? Okay, next. Ready. The last question on probability binomial distribution. In restaurant Bezos, 13% of the customers rated that food as poor. So 13% of the customers were saying that the food is poor. Okay, in a restaurant. 22% of the customers rated the food as satisfactory. And 65% as good. Okay. A random sample of 12 customers was chosen at random who went for a meal at restaurant Bezos was taken. Now, don't make sound kindly. Number 1, find the probability that more than 2 and fewer than 12 rated the food as good. More than 2, fewer than 12. What does it mean? It means what is given here? The x. X should be what? More than 2, less than 12. Less than 12. Clear, Baba? Okay. Rated the food as good. So now, which one is the probability of success here? The food is good. Clear? The food is good. This is the probability of success. So number 1. So n equal to 12 customers was chosen at random. So the probability of success is the food is good. And that's equals to 0.65. Is it okay, Baba? Clear? So the Q will be 1 minus P, that is 0.35, I guess. Clear? Now the question says what? The X should be more than 2, less than 12. So now if I ask Tazrian, what would be the values of X? Yeah. Starting from less than 2. Okay, starting from 3 to 11. So how are you going to do this calculation in an easier way? So the Tazian is saying that sir, X will be 3, 4, 5, up to 11. Then, so if I write down this thing, 3, 4, 5, 6, up to 11. So now if I ask Numair, so how are you going to do this calculation in an easier way? So you have to find the probability of this much. The total number of customers is 12, yeah. So Numair, if I ask you how to do it. Nusra, Aisha.
You find probability x equals to 1 and x equals to 12 and then 1 minus that.
No, one observation has been missed. What are the observations? 0, 1, 2. Clear, 2 observation has been missed. Clear, and there is a number 12 here. So what we can do, we can find the total probability 1. We know the total probability 1, and we can subtract x equal to 0, 1, 2, and 12. Clear? So that means the probability of x will be equals to 0, and probability of x equals to 1, x equal to 2, and 12. Okay, Azmain? Okay. So out of 12, it will be 12C0. So customer will tell it good and not good will be 12 customers. So that is 0.65 and this is 0.35. Next, out of 12, it will be one customer. That will tell you it is good and 11 customer will tell it not good. So 0.65 times 0.35. Next, out of 12, it will be 2. It will be 10. And out of 12, it will be 12 customer. So 0.65, 0.35. No, no, no. Oh, it will be from 1 minute. That's what, yes, yes. So it will be from 1 minus. Yes, thank you. So it will be from 1 minus this one. Here? So it will be from 1 minus because we have to find the probability by subtracting from 1. Clear? I made the mistake. I didn't subtract it from 1. Clear? Clear? So 1 minus the answer. So 0.993. Now, the next question is started from here. I forgot to give an enter. Okay, so on a separate occasion, a random sample of n customer who went for a meal at the restaurant was taken. Okay, so the number of trials are unknown. Clear? Next, find the smallest value of n. Find the smallest value of n for which the probability of at least one who will rate the food as poor is greater than 0.95. The probability of okay. So first of all, the probability of at least one will rate the food as poor. Clear? So what is X here? The people who are rating the food poor. Clear? The question says at least one. That means what? X will be greater than equals to 1. Clear? This probability is greater than 0.95. Clear? That means this is more than 0.95. Is it okay, Baba? It is the same as before. We did it last time at the we're buying something at least. Clear? Mahira? Sure? Confusion? Sure? No confusion? Okay. Samiha? No, I'm asking her. Oh, sorry. Samara. Samara? Is it okay? Okay. So now from more than 1, that means either 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 11, 12. What you can do, I can subtract the probability from 1 x equal to 0. Then I can subtract the x equal to 0 from 1. So that is 0.95. So 1 minus, okay, what is the probability of success here? Rating the food as poor. Clear, rating the food as poor. So how many of them rated the food as poor? 13%. So 0.13. So what will be the Q? 1 minus 0.13, that is 0.87. Clear, Baba? So now, out of n, it will be 0. So 0 people will rate the food as poor, and n people will rate the food as not poor. So 1 minus 0.87 to the power n, that is 0.95. So minus 0.87 to the power n is minus 0.05. So now we know in inequality, if you multiply with negative or if you cancel the negative sign, the unequal sign will be flipped. So that is 0.05, 0.87 to the power n. Now do the trial method. Is it okay, Baba? So the value of n, for which value of n, this value, this 0.87 to the power n value will be less than 0.05. Clear? So no matter what's the value,
Is it 22?
okay, so if you try, it will be, so 0.87 to the power 22, as Numar is saying, that value is 0.046, which is less than 0.05. So n will be 22.